Foundations of Amateur Radio. Recently I was asked about finding the best antenna calculator. It's a tool that helps you determine what the length of an antenna should be for a particular frequency. Picture a dipole antenna, two wires end to end strung out horizontally, joined in the middle by a feed point. A dipole is most effective if its total length is half of the wavelength of the frequency it's intended for. To calculate what that is, you divide the speed of light by the frequency. So for argument's sake, the wavelength for 28.5 MHz is roughly 10 meters, which makes sense since 28.5 MHz is in the 10 meter band. If you use your favorite search engine to find a dipole calculator, you'll find many different ones. If you try a few, you'll find the answers that each calculator gives is slightly different. For a half-wave dipole on 28.5 MHz, you'll find that there is a half-meter variation among the calculated answers. If you do this for a dipole for 3.5 MHz, you'll find the variation is just over 4 meters between the shortest calculated dipole and the longest one. That's a 5% variation across a calculated response. That's strange, since the calculation should be the same across all different calculators. So what's going on? Well, let's start with the wavelength. If you use the speed of light as 300,000 km per second, then a frequency of 28.5 MHz is 10.526 meters. But if you use the actual speed of light, there's a 7 millimeter difference. Right, simple. So there should be two types of answers, those that use 300,000 km per second and those that use the actual speed. Unfortunately, no. You could use a majority rules and pick the calculated answer that turns up most often. But science isn't a democracy. It's either correct or it ain't, and you have no way of knowing which is which. What you're actually witnessing when you see all these answers with the overall 5% spread is different approximations of the answer. Calculator is a word that implies precision and accuracy. But what's actually happening is that each calculator uses their own fudge factor to get closer to the starting point. It's all in an attempt to get an actual answer quicker. Since hoisting an antenna, measuring, lowering it, trimming it, hoisting it again and so on, is not fun with a 10 meter antenna, let alone an 80 meter antenna. Some of the fudge is related to how high the antenna is off the ground, the thickness of the wire used, if the wire has insulation on it, and how thick that insulation is, what the soil type is and what angle it's actually hanging at, to how far it is from other things. What this really means is that you need to experiment. When you buy wire, buy long, cut in little bits, measure lots and try it. A calculator will get you in the ballpark, but you already know the nominal length for a dipole as it is. It's right there, in the band name. So just because you found a fancy calculator online doesn't make it right for your circumstance. One tip, plot all the antenna length results from the various calculators and see what the curve looks like. You'll see a wonderful distribution curve that just begs to be used. I'm Ono, Victor Kilo 6, Foxtrot, Lima, Alpha, Bravo.